These notes will cover Unit 2, Lesson 2 on ionic bonds. So you are on page 3 of your green notes packet, section 7.2 in your textbook. So these notes will cover ionic bonds and properties. There is one term that I'm going to have you add to the top of your notes. I know there's not a whole lot of room, but the term polyatomic ion. So poly means many, and polyatomic ion is a group of atoms that act like one unit that will have a charge. So in your yellow packet, you actually have a list of several polyatomic ions. If you look on page 3, which is the table of ions, this chart in the middle has a lot of the common polyatomic ions. And if you look on the next page, which is the common ion sheet, any of these that have more than one element in them is a polyatomic ion. So even though they have more than one atom, they act like one group. So it's kind of like a package deal. So PO4 is phosphate. That whole group of atoms has a -3 charge. ClO3 is chlorate. That whole group of atoms has a -1 charge. So it's not like chlorine and oxygen are working separately. They are working together as a team. So I'll have you add that to the top of your notes. All right, then ionic compound and ionic bond. So ionic compound is a compound that transfers electrons between the cation and the anion. So remember from your first set of notes, the cation is losing electrons, the anion is gaining electrons. So when this transfer happens, that compound is forming an ionic compound. The net charge of any ionic compound is always 0. So you have a +1 with a -1, those two charges add up to 0. The ionic bond is the forces that hold those positive and negative ions together. So when ionic bonds are formed, each atom obtains or achieves that noble gas configuration. So sodium is going to lose electrons, chlorine will take those electrons, but both of those atoms will form that noble gas configuration. And we'll do an example at the end of this notes section. A few more terms that you'll see. Chemical formula shows the lowest whole number ratio of each element. So NaCl. In that compound, you would have 1 sodium and 1 chlorine atom. H2O, you have 2 hydrogens and 1 oxygen. So those are chemical formulas. Formula unit is another term for ionic compounds only. So you've heard the term molecule before. Molecule represents covalent. You'll add that later in the covalent section of your notes. But formula unit just describes ionic compounds. So if you see formula unit, that is just the description for ionic compounds. All right, here's some common properties of ionic compounds. They are usually crystalline solids at room temperature. So if you think about salt, salt is a crystal. They generally have high melting points, and they will conduct electricity only when they're melted or dissolved in water. So if you think about NaCl, here I'll try to draw it out for you. NaCl together, the positive and negative charges cancel out because all ionic compounds have a neutral charge. So NaCl as a solid would have no charge or a neutral charge. So here's our NaCl crystal. When you dissolve it in water, what happens is the sodium ions and the chlorine ions break apart when they are being dissolved. So now you have positive particles and you have negative particles. Whoops, that should be Cl minus. So when you have those positive and negative ions floating around in solution, that's when the solution will conduct a current. So ionic compounds will only conduct a current when they are melted or dissolved in water, because that's when those ions break apart. All right, one last thing in your notes that we'll have you add for today says to show the electron transfer between magnesium and chlorine as it forms a compound. And you'll do some of this in your interactive notebook as well. So Mg, you will draw the electron dot structure for magnesium. So magnesium, whoops, if you look on the periodic table, Magnesium is over here. It's in group 2, which means it has 2 valence electrons. So you would draw those 2 valence electrons. Chlorine is over in group 7, which means it would have 7 valence electrons. So we'll draw the 7 valence electrons around chlorine. All right, so magnesium, when it forms an ion, wants to lose those 2 valence electrons. Chlorine wants to gain 1 more, so it has a full 8 valence electrons. So one of these electrons, I'm going to switch colors here. One of these electrons is going to get transferred to this chlorine. So now chlorine is happy and stable. However, magnesium still has 1 valence electron that it needs to get rid of. So if that is the case, and if not all the electrons are completely transferred from both the anion and the cation, you're going to have to add another atom. So if we added another chlorine, each chlorine atom is going to have 7 valence electrons. So we'll draw those electrons in. So now, again, this chlorine wants to gain 1 electron. This magnesium wants to lose 1 electron. So now this electron will get transferred to the new chlorine atom. So now magnesium has lost both of its electrons. Chlorine has each gained 1 electron. So in order for the electron transfer to be complete, we needed 1 magnesium atom and 2 chlorine atoms. So when we write our chemical formula, we would write 1 magnesium atom and then 2 chlorine atoms. And when you write the 2, you write it as a subscript, which is a small number on the bottom after the element that it represents. So MgCl2 would represent that you need 1 magnesium atom for every 2 chloride atoms in order for that electron transfer to be complete. All right, that is it for the notes for section 7.2.